Hi class, in today's video we're going to be talking about section 6.3 and 6.4. And the reason I lumped these together is between the two sections there are 5 new types of formulas that I want you to be familiar with. The first 3 are the double angle formula, the half angle formula, and the power reducing formula, and so those come from 6.3 and 6.4, or 6.3, and then product to sum and sum to product come from 6.4. And what we're going to do is we're really going to dig into these first 3 quite a bit in detail, and then we're going to spend a little less time on the latter 2, because what I really want you to be able to do, the first 3 I think you should be able to explain where they come from, but the second, or the last 2, I want you to be able to just kind of use. And so if you go to your e-text on page 683 at the end of chapter 6, I'm going to highly recommend that you all make a copy of this, because this has our reciprocal, quotient, Pythagorean, and even odd identities we went through in 6.1, sum and difference, cofunction, and reduction formulas in 6.2, the double angle, power reducing, and half angle formulas in 6.3, and then our product to sum and sum to product formulas in 6.4. So you don't have to memorize them. I mean, I think there are certain ones you should. Particularly, you need to be able to know your reciprocal identities, your quotient identities, your Pythagorean identities, and your sum and difference formulas. But I think the rest of the ones, once you see how we get to them, you can just go ahead and kind of come up with them on the fly each time. So I'm going to leave this sheet here because I'm going to be using our Pythagorean identities, our sum and difference formulas, and so I'm just going to leave them here on the right side so I can grab them when I need them. And so, like I said, we're going to start with our double angle formula. And there are 3 of those. And so that's what we're talking about, is something that looks like sine of 2x, or cosine of 2x, or tangent of 2x. And again, we'll only do sine, cosine, and tangent because we can use our reciprocal identities to cosecant, secant, and cotangent. Now, the first thing to recognize is that sine of 2x is just sine of x plus x. And so if I have sine of x plus x, I can use my angle addition formula. Sine u plus v is sine of the first, sine x, cosine of the second, plus cosine of the first, sine of the second. Well, in this case, they're both x, so we have sine x, cosine x, plus cosine x, sine x. Well, those are the same term because both of them have a sine and both of them have a cosine, so it's really 2 cosine x sine x. And so that means that sine of 2x is really just 2 sine of x cosine of x. And so if we have an angle, we can use its half angle, the half of that angle, which is just x, to find our answer. And again, this is going to go back to using our unit circle, and after I go through the formulas, we'll work through some examples. So I won't do any examples now, we're just going to go through the derivation of each of these equations and formulas, and then we'll come back and look at examples. Well, for cosine of 2x, well, that's just cosine of x plus x. So that's cosine x, cosine x, right, because it's cosine, cosine, sine, 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 and that's cosine squared x minus sine squared x. So cosine of 2x can be written as cosine squared x minus sine squared x. And then what we can do is, so we have our Pythagorean identities over here that says sine squared equals 1 minus cosine squared. So I can do 2 different things with this. So by our Pythagorean Yep, I was making sure you could still see it. Pythagorean. We have cosine squared plus sine squared equals 1. Right, that's this one here. Which means that we can say cosine squared x is 1 minus sine squared x, or sine squared x is 1 minus cosine squared x. So we can replace cosine squared with 1 minus sine squared x, 1 minus sine squared x minus sine squared x. So we have 1 minus sine squared x minus another, so we have 1 minus 2 sine squared x. Or we can replace the sine, so we have cosine squared x minus sine squared is 1 minus cosine squared, 1 minus cosine squared x. Cosine minus a minus is a plus, so we have 2 cosine squared x minus 1. Which means that the cosine squared x minus sine squared x is also 1 minus 2 sine squared x and 2 cosine squared x minus 1. So we have 3 equivalent forms for cosine 2x. And then our last one, we have our tangent of x plus x. And then our tangent angle addition is tan plus tan over 1 minus tan tan. So that's tan x plus tan x over 1 minus tan x tan x. And so we can reduce that as 2 tangent x over 1 minus tangent squared x. So if we have tangent of 2x, we can replace that as 2 tangent x over 1 minus tangent squared x. And so see why I want you to memorize your sum and difference formulas, because it turns out in nearly all of our identities and all of our formulas, we use our angle addition to get to others. So here's our double angle formulas. So that's our first set of new formulas for today. We then have our power reducing, and so let me do my best to keep this on the screen. Power reducing formula. So what I'm going to go ahead and do first is I'm going to remind us of our cosine 2x. Now we said cosine of 2x with double angle formula was cosine, or I guess we can write this in either way, but we have cosine squared x minus sine squared x. And that's how we had it written right here, right? We said cosine of 2x was cosine squared x minus sine squared x. And then we said, well, we can go ahead and replace cosine squared x as 1 minus sine squared x. Right, so we had cosine of 2x was 1 minus 2 sine squared x. Now, if I move this 2 sine x to this side, and I move this cosine 2x to this side, I get 2 sine squared x equals 1 minus cosine of 2x. If I divide both sides by 2, I get sine squared x equals 1 minus cosine of 2x over 2. What happened? We had a sine square on this side, and we don't have anything with a power greater than 1 on this side. And that's why this is called power reducing. It lets us take a square to a non-square trig function. So our first of three is that sine square x equals 1 minus cosine of 2x over 2. I'm going to put a box around that, and I'm going to block off more space for the others. Now when we were working through this, we had a couple other forms. We're going to use our cosine 2x equals 2 cosine squared x minus 1. So this is, let me put a line there so we know it's over. Cosine 2x equals 2 cosine squared x minus 1. Add this one to the other side. So we have 2 cosine squared x equals 1 plus cosine of 2x. Divide by 2. Cosine squared x equals 1 plus cosine 2x over 2. And again, notice we went from a square to a non-square term. So our power reducing formula for cosine squared x is 1 plus cosine 2x over 2. And you know, if we've done it with sine and cosine, we're going to do it with tangent. Well, tangent squared. Move this up so we can still see. Tangent squared x is just sine squared x over cosine squared x. We said that sine squared x is 1 minus cosine of 2x over 2, all over 1 plus cosine of 2x over 2. Well, that's the same as 1 minus cosine 2x over 2 times 2 over 1 plus cosine of 2x. Those 2's cancel. And we then get that tangent squared x is 1 minus cosine 2x over 1 plus cosine 2x. So because the sine is over the cosine, we have the minus over the plus. Tangent squared x is just 1 minus cosine 2x over 1 plus cosine 2x. And so we have our double angle formulas. That lets us take 2 times some angle into just the angle itself. And then we have our power reducing. And what that lets us do is we can take sine squared, cosine squared to tangent squared, and we can reduce it to forms that don't have any squared trig functions. Now for our half angle formulas, and you'll notice my sequencing of this ends up being really intentional. So our half angle formula, and let me go ahead, I'm going to put them at the top since I like that better. If I have some angle over 2, cosine, tangent. Just made my life a little bit easier on that first page. What we're going to start with is our power reducing sine squared x equals 1 minus cos 2x over 2. So sine squared x equals 1 minus cosine 2x over 2. Right, that was our power reducing formula. And now I'm going to say let x be theta over 2. So we're just going to substitute theta over 2. So we have sine squared of theta over 2 equals 1 minus cosine of 2 times theta over 2 all over 2. Well, that just reduces to sine squared theta over 2 equals 1 minus cosine, the 2's cancel, cosine theta, all over 2. And if I want this by itself, because it's squared, I can take the square root of both sides. And so then I get sine of theta over 2 equals plus or minus the square root of 1 minus cos theta over 2. So notice here, if we have sine of some halved angle, example, thinking of it this way, suppose we had sine of pi over 8. We can think of that as sine of pi over 4 over 2. And since pi over 4 is on our unit circle, we can use this formula. So sine of pi over 8 is just plus or minus the square root of 1 minus cos pi over 4 over 2. Right, and so that's how we would use these sorts of formulas. I think the angle addition ones are maybe a little bit clearer and power reducing, right? Because we're not changing that angle inside. I think it's a little bit harder to see this angle over 2, which is why I wanted to introduce that. So sine of theta over 2 is plus or minus the square root of 1 minus cosine of theta over 2. Now cosine of theta over 2 we follow the same process with this function here. And we would end up getting plus or minus the square root of 1 plus cosine theta over 2. And now tangent of theta over 2 is just this over this. So we get plus or minus square root 1 minus cos theta over 1 plus cos theta. Make sure you draw your square root large enough to remember that both the numerator and the denominator are under that square root. And that's not the only form we have, because we know that we can do a little bit of algebraic manipulation on these. But if we were to rationalize this denominator, how about I do this on another page? So here are your 3 half angle formulas. But I'm going to look at this one on the next page. So here we have tangent of theta over 2. Tangent of theta over 2 equals plus or minus the square root 1 minus cos theta over 1 plus cos theta. So if I multiply the top and the bottom within that square root, 1 plus cos theta, 1 plus cos theta. Here we get plus or minus the square root of 1 minus cosine squared theta all over 1 plus cos theta squared. Well, 1 minus cosine squared is sine squared theta over 1 plus cos theta squared, which is just sine theta over 1 plus cosine theta. I lost my plus or minus. Why did I lose my plus or minus? Well, if I take the square root of 2 squared terms, the result can only be positive. And then our other form, copy this down, tangent theta over 2 equals plus or minus the square root. And now here we multiply top and bottom by the denominator. Now we're going to multiply top and bottom by the numerator. So we have 1 minus cos theta 1 minus cos theta over 1 plus cos theta, 1 minus cos theta, plus or minus the square root, 1 minus cos, 1 minus cos, 1 minus cosine theta squared over 1 minus cosine squared theta, plus or minus the square root of the numerator is just 1 minus cos theta. Square root of the denominator, well, that's 1 minus cosine squared is sine squared. And so for our tangent, we have three equivalent forms. We have the square root of 1 minus cos over 1 plus cos, but we also have sine theta over 1 plus cos theta, or 1 minus cos theta over sine theta. And those three forms are all on your formula sheet from the back of your chapter. Again, I'm not so concerned if you're memorizing all of them, but I do think you should be able to work through the algebra and get from one to another. So those are our half-angle formula. So in terms of what we needed to do today, all we have left is product to sum and sum to product. Product to sum. And so here, I'm going to start with, our old faithful, our sum and difference. And what I'm going to look at is cosine of x and y, x plus y, and cosine of x minus y. So if I have cosine of x plus y, that's cosine x, cosine y, cosine, cosine, sine, sine, sine. And if I have cosine of x minus y, I have cosine, cosine, sine, sine, sine. And let's add these together. You're like, well, that seems random, but bear with me. So here on the left, we have cosine x plus y plus cosine x minus y equals, so we have cos x cos y plus cos x cos y, which means we have two of those, 2 cos x cos y's. We have a negative sine xy and a positive sine xy, so those cancel. And so that says, if I divide by 2, that cosine of x cosine of y is just cosine of x plus y plus cosine of x minus y over 2. And this is our first of 4 product, right? Because those are multiplied to sum, because they're added. Our second, instead of adding these two, I'm going to subtract them. So I'll do cos x minus y equals cos x cos y plus sine x sine y. Cos x plus y is cos x cos y minus sine x sine y. So I'm going to subtract this one, so cos x minus y minus cos x plus y equals cos xy minus cos xy, means those cancel. Sine xy minus a minus is a plus, so we have 2 sine x sine y. That tells us that sine x sine y is just cos x minus y minus cos x plus y over 2. And that's our second product to sum. Hope I got cut off there at the very end. And so I don't think you need to memorize these. I think you should understand where they come from, and you should be able to look at your sheet, and then on the next, after I introduce the rest of the product to sum and sum to product, we're going to work through some examples, and being able to use these formula is what's important. So I'll give you your other two. So here we had cos x, cos y, and sin x, sin y. So they were the same trig function, but different angles. So our 2 for sin x, cos y. So now we have two trig functions and two angles. For this we have 1/2 times, or over 2, sine x plus y plus sine x minus y. And for cos x sine y, so notice they swap spots. The angle stayed in the same place, the trig function switched places. 1/2 sine x plus y minus sine x minus y. Now really, something, no, I don't know where I was going with that sentence. That's not how I want to start it. But these are our 4 product to sum formulas. You have 1, 2, 3, 4 of our product to sum. And I'm not going to work on any of the derivation for sum to product. Sum to product. Again, because my interest is in whether you can use them. So if we have cos x plus cos y, that's 2 cos x plus y over 2 cos x minus y over 2. If you have cos x minus cos y, well, that's negative 2 sine x plus y over 2 sine x minus y over 2 sine x plus sine y is 2 sine x plus y over 2 sine, nope, got ahead of myself. It's not sine, it's cosine. I was looking above and then I wrote the wrong thing. Cosine x minus y over 2. And then sine x minus sine y equals, and so notice here when we have a plus, this is the form, but when we have a minus, we have 2 sine, not x plus y, but x minus y over 2 cosine x plus y over 2. And those are your 4 sum to product. That's a lot of formulas. I know, I hear you. But let's go ahead and work through some examples. So I'll move these over here. Examples. If theta equals 3 over 5, find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Also for this, we have our double angle formulas. So we know that sine of 2 theta, which is 2 times sine of 2 times 3 over 5, is, and then looking at our formula sheet, 2 sine x cosine x, so that's 2 sine 3/5 cosine 3/5. Like, well, what triangle is that? theta is 3/5. Oh, that doesn't... I was thinking, in my mind, I was back to our previous lesson, or a couple lessons ago, where we had our inverse functions. And so, this is your answer. You don't need to simplify any further. Cosine of 2 theta is cosine x minus cosine squared x minus sine squared x. So that's cosine squared 3/5 plus cosine 2x is cosine squared x minus sine squared x. Gotta be careful here. Make sure we're looking at our formulas. Got a little ahead of myself. Tangent 2 theta. It's just 2 tangent theta over 1 minus tangent squared. So that's 2 tangent 3/5 over 1 minus tangent squared 3/5. And so all we were doing there was practicing working with our trig functions. We had our 2 theta for sine, cosine, and tangent. I don't know why I drew that arrow there. So this is our first example. Our second, rewrite sine square x cosine square x with no powers greater than 1. And so here we need our power reducing formulas. Well, sine squared x cosine squared x equals 1 minus cos 2x over 2, 1 minus cos 2x over 2. Cosine squared x is 1 plus cos 2x over 2. Well, and that equals, so we'll distribute 1 plus cos 2x and then minus cos 2x to cancel, minus cosine squared 2x over 4. Well, 1 minus cosine squared. Well, that didn't help us because now we still have a cosine squared. So cosine squared is 1 minus 1 plus cosine of 2, and this is where we have to be careful. If this is x, this is 2x. So this is cosine squared 2x. So this becomes cosine of 2 times 2x over 2 all over 4. I'm running out of space. So unfortunately I'm going to bring it over here. So I have 1/4, just so I can work with this a little bit easier. 1 minus 1 plus cosine 4x over 2. We can go ahead and distribute that through. We have 1/4 minus 1 plus cos 4x over 4 times 2 is 8. And get a common denominator here. So we have 2 minus 1 minus cos 4x over 8. 2 minus 1 is 1 minus cos 4x over 8. So sine squared x cosine squared x is equal to 1 minus cos 4x over 8. Again, being able to work with these trig identities using a reference sheet is our goal. Because never in the real world, when you're an engineer, a chemist, a physicist, will you ever have to work in isolation where they're like, you must remember these formulas from memory. 3. Half angle, find sine of pi over 8. And remember, this was this example I gave you where we could say, well, sine of pi over 8 is just sine of pi over 4 over 2. And pi over 4 is our 1, 1, root 2 triangle. So our half angle formula, if I can let me get to the next page. Half angle formula, sine of theta over 2 is, so here theta is pi over 4. So sine of theta over 2 equals plus or minus the square root of 1 minus cosine of pi over 4 over 2. That's plus or minus square root 1 minus cosine of pi over 4 is adjacent over hypotenuse, so it's 1 over root 2 all over 2. Work on simplifying this a bit more. Plus or minus the square root of, and I'm going to go ahead and put this under each, so half minus 1 over 2 root 2. 2 root 2s are common denominator, plus or minus the square root of root 2 minus 1 over 2 root 2. Let's go ahead and multiply this, the top and bottom, by root 2 just to get rid of that 2 and root 2 in the denominator. Remember, that's called rationalizing the denominator. Root 2 times root 2 is 2, minus root 2 over 2 times 2, which is 4. And the reason I did that is because now I can handle this square root a little bit. Plus or minus root 2 minus root 2 over 2. Just to be clear, that could have been your answer. But if it says to rationalize the denominator or simplify completely, you would need to go to that step. Find sine x, cosine x. And so now we have sine x, cosine, well in this case y equals x. So sine x, cosine x equals 1/2 of sine x cosine x is 1/2 sine x plus sine x minus x. 1/2 of sine 2x plus sine of 0. So let me write our unit circle. X is 1, y is 0, cosine sine. Sine of 0 is 0, so that's 0. Sine of 2x, we have a way to rewrite that. Sine of 2x. You're going to see what happens. So this sine x cosine x is half sine 2x. You can stop there. But we know that sine 2x is 2 cosine 2x. And so that's half of 2 cos x sine x. Those halves cancel, and look, sine x cos x equals sine x cos x. Okay, so that means we didn't make a mistake in our algebra because we got back to where we started. But you can stop there at half sine 2x. Another example, maybe working with some actual problem or actual numbers. Sine 25 degrees cos 5 degrees. And so here's our product to sum formulas. Move these over a little bit. We have sine and cosine. So sine x cosine. So sine 25 cos 5 equals half sine cosine. We have sine of 25 plus 5 plus sine of 25 minus 5, 25 minus 5. And so here we have half sine 30 plus sine 20. Now 30 is on our unit circle, 20 isn't, so we'd have to work with that to get something different. But that gives us an equivalent form of sine 25 cosine 5. Notice now here it's only in terms of sine. And then our last one, sum to product example, cos 3x plus cos 5x, cos something plus cos something equals 2 times cosine of those things added together, 3x plus 5x over 2 times cosine of those things subtracted. And actually, would anybody be terribly opposed if I wrote it this way? So that I could write this as cosine of 5x minus 3x over 2. I just don't want a negative number in there. So that's 2 cosine of 3 plus 5 is 8x over 2. Cos 5 minus 3 is 2x over 2. So that's 2 cos 4x cos x. And now we have a number of things we could do. We could work on our cosine formula here. We could break this 4x down using our double angle formulas. But to clarify, you could stop here. But we can go ahead and look at our cosine 2x's. So we could see, all we can do is we can introduce a cosine squared and a sine squared, or we can introduce a sine squared, or we can introduce a cosine squared. And I'm going to say generally speaking, our goal, our goal is to get rid of exponents, then powers, or exponents, then products, then sums. There isn't a hard and fast rule, and often what you'll see is it'll say verify that cos 5x plus cos 3x equals 2 cos 4x cos x. And what you need to do is see that you can use these steps in between. So this will be like that previous section where we had a lot of those verify type problems where it'll say, oh, or here it might say find the exact value of sine of pi over 8. And so here the exact value is this square root. Or it might say verify that sine x cos x equals half sine 2x. Or it'll say find your double angles if you're given your theta. But I do want you, so this is our end of our trig functions. I want you to be comfortable working with our double angle, power reducing, half angle, product to sum, and sum to product formulas. If asked, I think you should be able to show where these double angle or power reducing formulas come from, because they come from our sum and difference and Pythagorean identities. Ones that I think you should memorize because it'll serve you well in this class and in future courses: reciprocal identities, quotient identities, Pythagorean identities. I don't even care so strongly about even odd. It's useful, but I don't feel so strongly. Sum and difference, without a doubt. And even then, you only need to remember your cosine and sine angle addition, because tangent comes from your quotient identity above. Cofunction identities, you don't even have to memorize, because those come from sum and difference. And so that's, now that we're done with chapter 6, that's what I want you to take with you. I will see you in the next video, everyone. Have a great day.